Hello, thank you for using our ShinyBHB app. I am Sinan Yavuz, a member of the Bayesian Method for Education Research Group at the University of Wisconsin-Madison. The principal investigator of this project is Professor David Kaplan. In this video, I will provide a step-by-step demonstration of how to use ShinyBHB app. This is our project website, and if you are interested in learning more about our research on Bayesian historical borrowing, please check out our recent publications. You can see our recent publication here and open up the PDF file and read it through. To download ShinyBHB, I will go to our GitHub page. You can search on Google or in GitHub Bayesian Methods for Education Research /ShinyBHB, and you should be able to find this web page. Once you find this web page, you can go through and follow the instructions here on this website. You can also follow the instructions in this video. There is this green code button. After I click this one, there will be an option for downloading the whole package as a zip file. I will click on this and it will download it to my computer. Once I open this ShinyBHB main, and once I open up the folder, I will see many files, but we need server.r. I will go ahead and click on the server.r and open this via RStudio. It may take a few seconds to download, but once it's open, you should be able to see Run App button here. If you don't see this, try to download Shiny package and restart your RStudio. I will go ahead and click on Run App button, and it will automatically bring our ShinyBHB app. Here in the About tab, you can find more information about our team members and the Bayesian historical borrowing project. In this video, I will only demonstrate how to use ShinyBHB app for single level non-informative Bayesian linear regression model analysis and Bayesian linear regression with static and dynamic borrowing. You can find more detailed information about these borrowing techniques again in our paper. For two-level models and growth curve analysis, please check out our two other videos under this tutorial tab. To start an analysis, I will first go to the Data tab. And under the Data tab, the first thing that needs to be done is to select the dataset. For this, we need to click the Browse button and choose the dataset we would like to run the analysis on from the pop-up window. ShinyBHB can read Excel files, CSV, Stata, SPSS, and TXT files. This gives you flexibility and ease to use. We provided an example file with the ShinyBHB. First, I will go and find the downloaded file from the GitHub page. Here is a small United States sample file from PISA 2003 to 2018 that comes with ShinyBHB, which can be found under the data folder downloaded from GitHub. This dataset is only a small sample of what is publicly shared by OECD. For the purpose of this demonstration, we will run our analysis with this sample dataset. After we click Open and our data file is selected, it will automatically appear here on the right of the screen. This allows us to take a quick glance at the data. If you would like to see more rows, you can click on Show Number of Entries, and then you will have more rows. If you would like to see another page, you can click. If you would like to see the tail of the data set, you can click the biggest number here, and it will show you the tail of the data set. It also tells you how many entries or rows are in the data. It's always a good idea to check your sample size before analysis too, as not to miss anything. On the left side, it says level 1, We won't worry about this right now because in this video, we will only demonstrate single level analysis. First cycle is indicated as 1, which is the 2003, and the last one is 2018 PISA administration. The next selection is the dependent variable. In this example, the dependent variable we use the math achievement score, and our goal is to evaluate the effects of the different predictors on students' achievement. So I will go ahead, find the first plausible value of the math score. Note that the dependent variable can only be continuous. There is a little checkbox that says use longitudinal model, which refers to growth curve model analysis for longitudinal studies. You will find more information and demonstration of it on our video about the growth models. For the independent variable box, we can select multiple variables. However, be aware of that the software doesn't automatically separate student and school variables. Also, the independent variables need to be continuous or dummy-coded categorical variables. So it is only appropriate here to select student level variables, as this is an illustration for single level models. For example, we have public, teacher shortage, student-teacher ratio as school level variables. And the other one is student ID, which we won't need it at the current moment. The other student level variables are female, which is binary version of gender, language spoken at home, which is also converted to a binary variable coded as English and other than English, parent education, which is the highest education of parents in year, home pos, which is short for home possession, is a summary index of household and possession items, immigration, background, about whether the student is first generation in the US or not. So for this example, let's select female and also parental education. For single level analyses, we don't need to worry about the Add Level 2 button, as it is used for the multi-level model for cross-sectional data. After selecting the independent variables, we can move forward and go ahead, click on the Estimation tab. In the left side of the tab, we have the selection of type of borrowing, and middle or right side of the page, we have the model in an equation form. Under the equation, you can see the prior distributions and specify the hyperprior. For the sigma beta, which is the standard deviation parameter of all coefficients, only a fixed value can be selected under no borrowing. This can be seen as one limitation of this application. Under the sigma r, which is the standard deviation of residual variance, more options can be found. Based on your choice of type of borrowing, parameters will change and new boxes will appear or disappear. There is also a footnote indicating that the data have been standardized during the computation. Hyperpriors should be specified based on standardized data, and results will be converted back to their original scale by default. On the left side, under the type of borrowing, there are three selections: no borrowing, static borrowing, and dynamic borrowing. According to the selection here, options under the methods as well as hyperpriors on the right hand side will change. Let's click on the static borrowing. Now we have two options for the method: pooling and power priors. If you click on the power prior, the alpha parameter option for the power prior method will pop up, and the default value is 0.5. In here, you can update this parameter value to change the degree of borrowing. Note that 0 means no borrowing and 1 means complete borrowing. Because the most significant contribution of this Shiny app is the Bayesian dynamic borrowing, I will demonstrate specifically dynamic borrowing. But other methods also follow the same idea in terms of running them via the app. After selecting dynamic borrowing, only BDB will appear under the method section. Now we can go ahead and set up the priors we want to use for our analysis. Again, we will start with sigma beta. However, this time beta has a superscript, which represents all cycles, current and historical. For BDB, we will also set a prior for the distribution of mu beta. And finally, residual variance. After we determine the priors, we can go back to the left side and select the number of chains and iterations, also number of cores we want our computer to use, warm-up iterations, and thinning interval. Each chain can only run on one core, so if you have enough cores, it will be more efficient to select an equal number of chains for the number of cores. I will use the default options here, and I will go ahead, click on the Run button. Again, it is using RStan on the background of this app. After waiting patiently and following how the sampling process is flowing occasionally, from here down below, and when you see done exclamation point, you will know that your analyses are done. Now we can go to Diagnostics and see whether our algorithm has converged. On the left hand side, you can select the parameters, and on the right hand side, you can see the density, trace plot, and autocorrelation plots. Here it says max R hat, cycle all, and it gives us the value. This is the maximum R hat value found among all the parameters in all the cycles. So note that R hat values should be less than 105 and ideally less than 101. When you change the parameter, let's go ahead, click on beta 0, you will see that individual R hat value for the specific variable. If you would like to report these plots, you can simply click on export density or trace or autocorrelation plots. It will download automatically to your computer. Once we are done with the diagnostics and have made sure that convergence is satisfied, we can go ahead and click on the Results tab. On the left hand side, we can see our model for references, max R hat, and LUIC values. LUIC is only meaningful when we are comparing multiple models. Now, on the right, we have the single level Bayesian dynamic borrowing results of a small sample of pizza. It's worth mentioning that these results were produced after borrowing information from all 5 previous cycles. So this table has the same structure that RStan produces because, as I mentioned earlier, this software uses RStan on the back. We have the mean value of the coefficient, standard error of the mean, standard deviation, credible intervals, effective sample size, and R hat values on the table. ShinyBHB allows users to export their results table in a CSV, Excel, or TAC format. We hope that you find the ShinyBHB and video useful for your analysis. If you have any questions, please feel free to reach us by clicking the About tab and email us link. Thank you.